Hello, everyone. Welcome back to our mini lecture. In the previous lesson, we have learned about the delayed flashing control of a single LED using a microcontroller. Today, we will continue by exploring the control of LED lighting using diodes. Specifically, the design of running light circuits. Now, we will cover the following topics. Using the example of city night neon lights, let's watch this video. We see that the lights creating these colorful scenes follow certain rules, with a primary form being sequential lighting. In the previous lesson, we used a microcontroller to control the flashing of a single LED. The principle was to connect one end of the LED to the microcontroller's I/O port and the other end to the power supply. By controlling the output voltage of the I/O port, we achieved the LED's flashing. The running light circuits involve sequentially lighting up a series of diodes, for example, from the first to the eighth diode, which is known as shift lighting. In principle, the first and eighth diodes are equivalent. In this circuit, we use the P0 port, with components similar to those used in the previous task, but in larger quantities. We have already mastered the method for lighting diodes. The key problem in this task is how to achieve sequential lighting. Based on our existing knowledge, we have listed the correspondence between P0 port output values and the states of the LEDs. Observing the changing patterns of the P0 port output values, it is easy to relate this to a C language operation. Shift operations. Shift operations are divided into left shift and right shift. The table shows the syntax and rules for shift operations. Clearly, this example involves left shift operations. Let's look at an example to help us understand shift operations. A hexadecimal unsigned number 0xEF in binary form is 1110, 1111. Now, if we left shift this unsigned number by 1 bit, the operation format is x shifted left by 1 bit. After shifting, it becomes 1101, 1110. The leftmost bit, marked in yellow, is shifted out, and a 0 is added at the rightmost position, marked in red. The right shift and left shift operations only differ in direction, while their operational rules are identical. In this example, we start by resetting the P0 port, setting P0 to 0xEF, which turns off all the LEDs. We also initialize the variable x to 0xFE. Note that x is initially set to 0xFE, so the value of the P0 port remains 0xFF, and the states of the 8 LEDs do not change. Next, we set the value of x to a negative value for the P0 port, changing the value at P0 to 0xFF, with the least significant bit of P0 being P0.0. This outputs a low level, turning on the connected diode D0, which stays lit. The value of x is then left shifted by 1 position, resulting in 0xFC. To turn off D0, we perform an increment operation on the shifted data, changing x to 0xFD. We enter the second iteration, setting the value of P0 to x, so P0 changes to 0xFD and D0 turns off while D1 turns on. This process continues through 8 iterations, lighting up D0 through D8 in sequence. After completing these 8 iterations, the process starts over for another 8 iterations. This accomplishes the desired shifting and lighting sequence. Based on the analysis, let's design the control program for the circuit. The control program consists of 2 main functions. Delay, which is a delay function we have previously discussed. Here, It employs a nested two-layer loop structure with a while loop containing a for loop. The body of the for loop is enclosed in curly braces, and the inner loop is entirely encompassed by the outer loop. Through these two examples, let's summarize the usage of the for loop statement. Pay particular attention to the syntax of the loop condition within the parentheses following for. The three expressions within these parentheses are separated by semicolons. And note that there is no semicolon after the third expression. In the main function, the first statement is a variable definition. The main function body consists of a two-layer nested loop, with the outer loop using a while loop and the inner loop using a for loop. Through the examples in previous and this lesson, note the coding style in C language. Curly braces should always appear in pairs, and each pair of braces and its contained statements should be indented to naturally express the program structure, making it clear and readable. This is a good programming practice. Compile and link the control program. Click the simulation button and observe the actual control effects. Changing the number of loops in the delay function can adjust the delay time. Today we learned to design a running light circuit using a microcontroller, involving shift lighting of LEDs on the P0 port. Through case analysis, we gained a deeper understanding of the control functions of microcontrollers and further insights into nested C language programming. We also studied C language shift instructions and became acquainted with the programming style of C language. After class, you can try implementing reverse running lights to become proficient with the related concepts. Also, please complete the following exercises related to this lesson. That concludes this lesson. See you next time.